Now we're going to take a look at each line of our little Hello World program just to make sure that we truly understand what is going on here and to give you a little bit of just overview of what is happening in the program and what these different parts of the program are called. You're going to see all of these different areas that I talk about in more detail as we go on through the other chapters of our course here. But I want you to have a good idea of these different sections and how they kind of work together. The very first line there is a pound include. That pound hash mark in the first column there is a preprocessor directive. That's what we call that. There's a program that's part of the C compiler called the preprocessor that goes through and looks at the code and does a lot of replacements and checking and other work before the compiler is allowed to take the pre-processed source code and start creating a program with it, start creating object code from it. So that preprocessor directive, and we'll see that there's quite a few of them. Include is just the one we're using here. That directive is acted on before the compiler ever sees this program. And what we're doing here is we're including another file called the stdio.h. That's a header file. That .h is a standard in the C language to say that this is a header, and that is going to bring in information to support standard input and output. We don't do a lot with the standard input and output here in this particular program, but it's always a good idea to have this include because most programs will want to get information from the outside world and need to say things to the outside world. So standard I/O is typically needed. The less than and greater than symbols that you see around standard IO.h tell the preprocessor to look for this file in the common include area that's been defined to the compiler. We'll get into all of that when we talk about preprocessor directives and how that works. If we had double quotes around there, around standard I/O, we would be telling the preprocessor to look for the file in a location that we set up, not the normal include area where the preprocessor should look for common header files. So that's our preprocessor directive. The pound sign is usually in the first column, though it doesn't really have to be. You can have white space in front of that pound sign, so it can be moved over a few spaces. But for readability and the common look of C programs, that pound sign is almost always in that first column, just like you see it. And notice that there is not any kind of an end of line character there. There's no semicolon or anything like that after the standard IO.h and the greater than symbol there, the little arrow pointing to the right. Nothing has to end that line. This is main. This is our function definition or function declaration, we can say. And what we're doing here is we are defining what the main function will actually do if it is ever called. Now, we will be defining a lot of other functions as we go through the course. This one, though, is special because it is called main. That is a reserved name. We can't have any other functions called main. And if you have more than one, of course, that's an error. But the one main function of any program is the one that the operating system knows to start the program with. And the compiler, when it creates our object code, looks for that word main, looks for that function and says, okay, this is where things are going to start. And that's where your program will begin, and where it goes from there is up to you and your user and things like that. But the program will always start at main. There's an open and close parentheses right after main. There can be white space after the end. There can be a space there. I just haven't put one. It's okay if there's not. The parentheses will hold parameters that get passed from the outside world into main. And when we look at those kinds of, they're called arguments, when we look at those later, you'll get some detail on how to get information from the outside into your program. And that's how we interact with the World Wide Web as well. We take information in through through those parentheses and get it inside our program and do something with it. Notice also there is no semicolon after that closed parentheses because we are defining a function here. We are not calling it. We are not asking it to be performed. We are saying this is what is inside main and how main works when somebody eventually wants to call it. The open brace and close brace, that's a statement block. Main could be just one line, and in our case it is. It's just that little printf down there. So we really, technically, don't have to have the braces for this main because the single statement would be okay. Not a very useful program, though, if your main only has one line to it, but that's why you normally want the braces. So we have our open brace and close brace, which will contain all of the statements of this function. When I start programming, I put the open and close brace right next to each other, and then I hit enter a few times inside them and open up the space a little bit. That way I don't ever forget to put that closed brace on there, because that will cost you a lot of time looking around for a missing brace if you don't have those matched up. So that's our defining our function main with the braces. And now let's move on and look at what's inside there. There's our printf function. Now this is a function call. We are not saying here, of course, what printf does. We are asking it to do its job. We know what print formatted does. It's going to put stuff out to the outside world, and it's going to do it and make it nice and pretty. And it also can pass all kinds of information from our program to the outside. When we get to printf, you'll see quite a bit about it. Printf is very powerful. It is included in the standard library that's included with the C compiler. It will always be there for you if it's a standard C compiler, so you can rely on it being included. So we have our printf. Again, there can be white space after the F and before the open paren. And then we have our parenthesis, and then the closed paren is on the other side over there before the semicolon, and that is a function call. That's calling printf. The hello world inside quotes there, that's just getting sent to the printf. And then the printf takes in whatever it's sent and acts on it. When we talk about printf, we'll see how it acts on all kinds of things that you can send it and tell it to do. Here it's pretty simple. It's just going to put this string, we call it, to the outside world. So let's keep going after our printf call. Now this hello world inside double quotes is a string literal. This is a number of characters one after the other, HELLO space WORLD, and then the \n is a single byte inside there. It's our carriage return, or actually new line is what this stands for, the \n, but that takes up a single character. And then we're going to find out later in string literals that there is really a null, an all zeros, all bits turned off byte stuck at the end of this thing. And that's hidden away in there. We don't see that right now, but that's how C strings are made up. They're a bunch of characters put together in memory with a null byte, a no value byte stuck at the end. That lets C know where the string stops. And where it starts is the address of the beginning of the string, and we'll get to all that. But don't want to overload you with all that right now. But the hello world inside double quotes is going to be passed into printf so it can do something with it. Very important little semicolon out there at the end of the line. That is the end of that statement, end of line, end of statement character, has to be there for that printf to work. That says this is a piece of work that you need to do. We're not defining another function or anything like that. We're actually causing some work to be done. So that semicolon says this is a statement for you to execute, compiler, and that's the way the compiler will treat it. That is our whole program. As we've seen it, you've learned a lot. You've used preprocessor statements. You've defined a function. You've called a function. You've passed parameters, and you have your little statement in there. So good job. Good job. In our next piece of work here, we'll talk about a programming assignment, and then we'll have a program answer after that. So stay tuned.